You see it everywhere, right? AI is getting smarter, faster, and more capable every single day. And it's forcing us to ask this huge question, one that used to be just for science fiction movies. It really gets to the heart of what it means to be, well, us. So let's just go there. Could an AI ever truly be conscious? To even have a shot at answering that, we have to grapple with what consciousness even is. And right now, the whole debate is basically split into two big camps, with two totally different ideas about how a mind works. Okay, so on one side, you've got the mind as software team. Their idea, which is called computational functionalism, is that consciousness is basically a really, really fancy program. It's all about the pattern of information, the computation. And if you run that program, it doesn't matter if it's on a silicon chip or human brain, boom, you get consciousness. But then, on the other side, you've got the mind as wetware folks. They argue the complete opposite. They say the stuff you're made of, the messy, squishy biological hardware, is everything. The body matters. So to really get why this split is so important for AI, let's start by looking at the world that all of today's AI systems actually live in. Right, so let's talk about the digital computer. It's the foundation for literally all modern AI. And its entire philosophy, its whole reason for being, is built on one simple, powerful idea. And that idea is separability. This is the genius, and maybe, just maybe, the biggest limitation of digital computers. Think about it. The hardware, the physical chips, are totally separate from the memory that holds the data. And that's separate from the processor that does the actual thinking. Everything is in its own clean, tidy little box. And this amazing design, this separation, is the philosophical bedrock for that whole mind as software idea. I mean, it makes sense, right? If the software is completely independent from the hardware, then, in theory, you should be able to run a consciousness program on any computer that's powerful enough. The physical machine itself becomes irrelevant. This is the blueprint for everything, from the phone in your pocket to the enormous server farms training large language models. The software they use is designed from the ground up to not care what specific hardware it's running on. It's an incredibly powerful system, but as we're about to see, it's a universe away from how your brain works. Okay, so now let's pivot and look at the biological mind. Because if the digital world is all about clean separation, the biological world is about a deep, messy, tangled up web of connections. You know, we love to think of the brain as some kind of biological computer. We picture this neat and tidy network of nodes and wires, kind of like an organic circuit board. It's a simple, comforting idea. The only problem is, it's completely wrong. Because the reality of the brain is infinitely more complex. It's not built in these neat, separate layers. It's a deeply interconnected, well, it's a glorious mess. What's happening down at the tiniest molecular level is completely tangled up with what's happening across huge regions of the brain. And this right here is the absolute key point. The fundamental design principle of the brain is the exact opposite of a digital computer. Its magic doesn't come from keeping things separate. It comes from weaving them so tightly together that they become inseparable. There's a name for this: scale inseparability. It basically means you can't just slice the brain into different levels, like a software layer and a hardware layer. The tiny little dance of ions in a neuron, the firing of that single neuron, and the giant waves of electricity washing over the whole cortex. It's all one continuous, deeply connected system. And get this, it doesn't just compute in one way. The brain is a hybrid computer. It uses these discrete, digital-like signals. You've heard of them, the all-or-nothing spikes from a neuron firing. But at the exact same time, it's humming with continuous, analog-like information carried in these electric fields that ripple across millions of cells at once. So the big question is, why? Why on earth would evolution build such a complicated, tangled, and seemingly messy machine instead of a nice, clean digital one? Well, the answer comes down to one thing. One massive constraint that rules all of biology. Check out this number. It's kind of mind-blowing. Your brain makes up only about 2% of your body's weight, but it burns through 20% of all your energy. It is an incredibly expensive piece of equipment to run. See, unlike our AIs, which are plugged into a grid with basically unlimited power, the brain evolved under conditions of extreme energy scarcity. Every calorie counted. And that constant pressure forced it to find a totally different, hyper-efficient way to get things done. So all that weirdness, the inseparability, the hybrid signals, those aren't bugs. They are features. They are brilliant evolutionary hacks to save energy. Okay, so let's bring this all back to our original question. What does this all mean for building a conscious machine? Well, this deep dive into biology suggests that maybe, just maybe, software alone isn't going to cut it. The challenge might be way bigger than we thought. So here's the big idea, the major takeaway. Consciousness might not be a thing you can find at any one single level. It's not just in the software or just in the hardware. Instead, it might be an emergent property that arises from the constant, dynamic conversation happening between all the scales at once, from the molecule all the way up to the mind. You see how this just flips the whole problem on its head? We're not just trying to write a better algorithm anymore. We might actually have to build a whole new kind of physical thing. So, if we were to do that, what would the recipe even look like? Well, if we take your cues from the brain, here are the ingredients. First, you'd need hybrid computation. It has to use both those digital-like spikes and those analog-like fields. Second, it has to have scale inseparability, where the tiniest parts and the biggest systems are all tangled up together. And finally, its physical structure has to be dynamic. The hardware itself has to be able to physically change and rewire itself as it learns, just like our brains do with neuroplasticity. And when you put it all side by side like this, wow, the difference is stark. Today's AI is built on the exact opposite principles. Where AI has separable hardware, the brain has inseparable wetware. Where AI has functionally unlimited energy, the brain is ruthlessly efficient. And where AI is purely digital, the brain is a powerful hybrid. This all suggests that the road to artificial consciousness might not be paved with bigger data centers and more powerful GPUs. The path forward might require a radical shift, building totally new kinds of hardware, things that compute with fluids or ions, using the same physical tricks as living cells. We might need to stop trying to build better computers and start trying to build something more like a living organism. And that leaves us with one final, pretty profound question to chew on. If consciousness is truly inseparable from the physical, energy-starved, tangled web of biology, what does that mean for Quest? Does it mean that to create a truly conscious mind, we might first have to create a new form of life? Now that is something to think about.